why we're seeing what we see. We can say that things are related, but we don't know that one causes the other. One reason for that is confounding, when the effects of two or more variables can't be separated. We don't know if those seniors were more likely to be hospitalized without the flu shot because they didn't get the flu shot or because they had other health issues. I don't know which thing caused which. So that is confounding. You can't separate the two. We can say there's a relationship, but we can't say one caused it. A lurking variable is just anything that maybe had an impact, but we didn't think about it. We didn't even consider it. Like maybe those seniors that got the flu vaccine, maybe they
also got some other vaccine.
Right, maybe they had another vaccine at the same time. We didn't think about what other vaccines they had, but would having other vaccines potentially impact their health? Absolutely. So confounding is just when we can't tell which thing caused which. The lurking variable is something that had an impact that we didn't even think about, along with a certain characteristic. So if I wanted to know if the seniors in senior housing in Monroe City got their flu shot, it would be a list of every single person living in the senior housing in Monroe City and if they got their flu shot or not. So just like when you hear census, you probably think of the census where they count everybody in the United States, right? That's what this is. You're listing everybody in the population you care about. Kind of talked about before. Ideally, you want to be able to talk to everybody in a population, but it's not always feasible, right? If I wanted to know if the senior citizens in senior housing got their flu shot, is it feasible that we could go knock on every door and take a poll and ask them, did you get a flu shot this year? Yeah, we're in Monroe City. It would be feasible. Now, if I want to know if every single senior citizen in the state of Missouri got a flu shot, no, that is no longer feasible for us. So ideally, you would talk about the whole population, but most of the time you can't. So where we're going next is how do we get a good group to poll? Now, if I just went to senior housing on 2nd Street and asked all of them, do they represent the entire state of Missouri? No, that would not be a good sample. So even if I got a certain statistic from them, it really wouldn't mean anything. Random sampling is how we can use chance to select people to be included in our sample. So random sampling, there are lots of more specific ways we can do it, and we will talk about them, but this is just your general. Random sampling, if I want 3 volunteers and I pick your name out of a hat. When we do the big spinning wheel in the gym to see who wins the prize, that's random sampling. Okay, we are randomly selecting who gets chosen. And in this, in true simple random sampling, everybody has the same probability of getting selected. So if you'll notice on your sheet, you have random sampling, just our general definition. And then we have boxes that I'm talking about the different types, and I put diagrams in there that we'll look at. We will define simple random sampling again in a minute, but basically what I would write in that box is simple random sampling. Every possible sample has an equally likely chance. Nobody is more likely. Nobody got their name put in the hat twice. You all get the same chance of being selected. Random sample just by hand. So let's say a study group consists of 5 students. Bob, Patricia, Mike, Jan, and Maria. 2 of the students must go to the board and demonstrate a homework problem. List all possible samples of size 2. Without replacement means you can't be your own partner. Okay, so if Bob gets selected, you can't just say the 2 people are Bob and Bob, which makes sense, right? It has to be someone else. So, what would be my samples? Can I just do like B, M, I, J, and M, A? I'm going to abbreviate. So give me every sample that includes Bob. Bob and Jan, Bob and Maria. Now, does order matter in this? No. If I were lining them up at the door, would it be necessary, like could it be different if one person were in front of the other? Yes, but when I'm just picking two people to work the problem, order doesn't matter. So those are the samples that include Bob, okay? Now give me everything that with Patricia. We already have Patricia and Bob, so then we would have Patricia and Mike, Patricia and Jan, Patricia and Maria. Okay, so we've done these two. Give me everything involving Mike. Mike and Jan and Mike and Maria. And the last one we have. Okay. Those are all my samples. What is the likelihood of a sample containing Bob and Jan? How many of these combinations are Bob and Jan? One. Okay, so then that would be 1 out of how many people, or how many different? 10. So there's a 1 in 10 chance that Bob and Jan get selected to come to the board. All right, so we just created simple random samples there. And every sample is equally likely, right? The probability that Jan and Maria get selected is also 1 in 10. The probability of Mike and Bob would be 1 in 10. Every group is equally likely. To get the simple random sample, sometimes we use random numbers to do that. So like if I wanted to group in the high school, I might take an alphabetical list, everybody gets a number, and then randomly select numbers. There are different ways to do those. There's a random number table in your textbook, which basically is just a chart full of numbers. And you would go through the chart and just say, okay, I'm going to pick the first 5 numbers in this chart. So there's those. You can use a table that's already been generated. We can also use our calculators to get random numbers. It's not truly random because it actually does have a formula for how they calculate it. So, to do this, if we are working on our calculator, first you have to come up with a list of everybody that you want. So, I would have a list from, if I were looking at people in this classroom, 1 to 10. Okay, I'm going to randomly select somebody from this class. I'm going to use my calculator to pick that person. So, to do that, first you have to give your calculator a starting point. So I'm going to pick a number. Do we have this? I may not have put it on your note sheet, sorry. I was just going to show you how. So you pick a number. Let's put in a 5. And then you are going to select the STO button and puts a little arrow on here. And then we're going to go to math. You see that under the green button? Is everybody with me so far?
Yeah.
And then at the top of the math menu, so you've got math, number, complex. The last one, PRV, is probability. We will use that one a ton this semester. And from that probability, we want number 1. Okay, and then if you hit enter, it just comes back and says 5, right? What we did is we stored it. It has a formula for calculating a random number. We gave it a starting point. So now, to actually get our random number, we are going to go back to math, probability, want number 5, which says random integer, and then it has parentheses. Okay. So in that, in your parentheses, the first number has to be your starting point. So I'm going to say I want a random number between 1 and 10. So I'm going to push 1. Then you need to enter a comma, which is above the number 7. And then you do your endpoint. So 1 and 10. And if you hit enter, what number does it give you? 8. We all got 8 because we all started with the same starting point, number 5. That's just like your starting number. I wanted to give me something between 1 and 10. So you push 1, comma, 10. Oh, sorry. And then you go back to probability.
Okay, well, that's because I did it the second time. But you.
You're welcome. And we can kind of experiment with this. The first part you don't have to do, and if you come in and pick up a calculator, as long as the memory hasn't been wiped on it, if there's ever been something stored in there, you don't really have to worry about that. Okay? But it has to have that starting point, so if the memory's been cleared, it might shoot back an error if you don't put 1 in. But let's try to get, why don't you guys get
I think that was why mine didn't work.
try to get a random number between 1 and 75. So you just go math, probability, number 5, we're doing 1 comma 75. All right, did you guys get a number?
Here's what I did.
Oh, it's because
It just had that.
Go target 67.
the nice thing, if I wanted another number between 1 and 75, if you just hit enter again, it's going to keep giving you numbers. So if I needed a group of 6, I could just keep hitting enter and it would keep giving me numbers.
A very low chance you need 67.
Wait, your second one was 67? Right.
No.
Oh, I
Yeah,
got 68.
Stupid. We didn't start at the same time.
Right. Okay.
Theoretically, if I do it 75
You have a chance.
It's a chance, but not guaranteed.
Okay, so let's do, I want you guys to see if you can try this one on your calculator. Let's think about what we need to do. The 112th Congress of the United States had 435 members in the House of Representatives. So how could I get a sample of 5 members? What would I have to do? We wouldn't have to start at 5. Where would we? 1.
And then you just do it.
And actually, if you even, when you type it in, so if you do your random integer, you do 1 comma 435, you can actually put another comma and say 5, and it will give you 5 numbers from that list. So you can, if you don't want to just keep hitting integer, you can do your random integer, 1 comma 435, and instead of hitting enter, put 5, and you're telling it that you want 5 people from that list. And so as long as you've assigned a number to everyone, you'll get there.
Do we write it down or?
Sure.
So it's between 1 and 435, and you want 5 of them.
Yeah.
You left.
All right. So that is technically the end of these 2 sections. I want to start the next section, but I also want to give you guys some time to do homework. Do you want to do homework first and then intro to the next section at the end?
Homework.
Okay, so I'll give you guys some time to work and then we'll come back and look at the next section.
Just take as long as.
Started off, I've mentioned simple random sampling. We know we could list everybody, generate random numbers, but that does have its faults as well. You know, if I did that in high school and I was trying to get a sample of 30 people, is it possible that it might give me 20 seniors and no freshmen at the end? Yes. Could that potentially be an issue in what I was doing? Maybe so, yeah. So we need some other options for how we get samples and kind of picking a good option depending on what our strategy is. So I broke it into pictures on your diagram and on your notes packet, and you can kind of write your definitions in there. So a stratified sample is basically when you divide everyone into a group first. Do you guys want me to let you write and then talk? Do you listen to me if I'm talking while you're writing? Okay. So simple random sample might be everybody in the high school gets a number. I randomly select 40 people from those numbers. Stratified is I first put everybody into a group. So maybe it's freshmen, sophomore, junior, seniors. There's none overlapping. Nobody belongs to two of those groups, right? The strata is your class. That's how I decided what group you belong to, was your grade. And then from within that, we take a simple random sample from each. So I have 4 groups, I want 40 people, so I randomly take 10 from each of those groups, right? Why is that better than just taking 40 from everybody? Right, I know it's more balanced, right? I get exactly 10 from each grade level, if grade level is important for whatever I'm looking at. Systematic is by selecting every Kate individual. So maybe I stand at the lunch line and I say, okay, I'm going to talk to every 20th person that comes through. I don't know who I'm going to get, but I'm getting a good mix of people, right? Everybody has that chance of being selected, but every 20th person, I talk to them. That's systematic. Cluster is obtaining everybody in a certain group. So it might be, I walk in Mr. Dabney's room and I say, okay, everybody in here, tell me your opinion on this. Everybody in the high school is currently in a cluster, everybody's in a classroom, right? But I randomly select a couple classrooms and I talk to everybody within those groups. So maybe I'm going to talk to Mr. Dabney's group, and I'm going to talk to Mrs. Weldon's group, and I'm going to talk to Mrs. Comstock's group. Okay, so I randomly selected groups, and then everybody in there gets pulled. All right, do you guys understand those? Do my diagrams make any sense at all? How we're selecting? So probably not a great option, but another one is convenience. What do you think convenience means? Whatever's easy. So maybe I just stand outside my room between classes and I ask the people that walk by me. Maybe I ask you guys because you're sitting in my classroom. So a convenience sample is just based off. Let me go ahead. Thought I had that. All right, let's just write that in. So a convenience sample is just what's easy. Any group that I can easily select.
Arguably the easiest or second easiest way to get bias.
Exactly.
The only way that might be worse about getting bias is cluster.
Because everybody tends to have something in common if they're in that group to begin with. Multi-stage sampling is just a combination of techniques. So maybe I start off with cluster sample and I have several groups and then I randomly select from within my group. So multi-stage is just a combination of techniques. Convenience is what's easy. Multi-stage is combination.
You say that again.
Convenience is what's easy. Multi-stage is a combination of techniques. So I do more than one of those things above. What's working again? Right, let's look at this one on our examples, and that might be where we leave off today. In 2008, the United States Senate had 47 Republicans, 51 Democrats, and 2 independents. The president wants to have a luncheon with 4 Republicans, 4 Democrats, and 1 other. How could I get a stratified sample to select my members? And what would make it stratified? Yep. Okay, how do I get, what are my groups? And then to randomly get within my groups, what would I do? Yeah, how would I?
Random sampling.
Yeah, use your calculator. Get your random sample. Let's practice that. So we all have a number stored already, so we can go to math probability. Number 5. For my Republicans, it would have to be between 1 and 47, and I want 4. So 1, comma, 47, comma, 4. And you may get different ones depending on what number you had stored as your starting point. But these are the people that I got. Okay, your Democrats, same thing, except if you just hit second enter, you have to go back and change that 47 to a 51. And then our other, just randomly get a number between 1 and 2. So mine gave me 1. So that is a stratified sample. Everybody belonged to one of the groups. We randomly selected from within the groups. All right. I'm going to stop there. We'll pick up with this tomorrow.